Alright everybody, this is Miss Simmons, and this week you guys are going to be learning about Newton's three laws. This specific mini lesson we are going to focus on Newton's second law and how to calculate Newton's second law. Alright, so first, what is Newton's second law? Well, Newton's second law is most known as force equals mass times acceleration law. Which basically means that the force is equal to the object's mass times the acceleration of the object. Or more simply, the larger something is, the more force is needed to accelerate the object. Now, how are we going to calculate Newton's second law? In order to calculate this equation, you will need to do a little bit of math. There is some algebra involved in solving Newton's second law. So you need to have at least two of the variables known of the three. Alright, so those three variables are force, which is measured in newtons. We also need to have the mass, which is measured in kilograms, and the acceleration, which is measured in meters per second squared. Now, we're going to do a couple of examples to show you how to calculate Newton's second law. So we have our two knowns here. We have mass and acceleration. So since we have those two, we are able to find the force. All right? So what we are going to do, we're going to look back at our equation, which is F equals m times a. And we are just going to plug in the numbers for our knowns. All right? So because we know mass and acceleration, we can just plug in the numbers here, and we get F is equal to 30 times 4. And we do our math, and 30 times 4 is equal to 120. And remember that our units are newtons, so F is equal to 120 N, or newtons. Now in our second one, we want to do the same exact thing. We have our mass and we have our acceleration. So we're just going to plug the numbers into our equation. And we are going to get 72 times 14. And that is going to give us 1008 newtons. Now, what do you do if you already know the force? Well, here's where our algebra comes in, and I don't have a transition on this slide, but we're just going to keep going. All right, so we are going to find the mass of the object this time, and since we have the force and the acceleration, we are going to solve for the mass. So we're going to do a little bit of algebra, and on each side, we are going to divide by A. All right, the reason that we divide by A is because we want to get this M by itself. So in order to do that, we have to do the same to each side in an algebraic equation. All right, and we know from third grade math that any number divided by itself is 1, right? All right, so that will cancel out these two A's right here. Let's draw our little slash marks. All right, that cancels those two out, and we have just this M here. All right, so when we put our equation in, we end up with 12,000 divided by 16, or F divided by A is equal to M. And our number here is 750 kilograms. All right. Now, what if we have the mass and we have the force? Well, now how do we calculate that? Well, what we're going to do is find the acceleration of the object. All right, so we have our force, which is 1,792 newtons, and our mass is 56 kilograms. So we are going to solve our algebraic equation, and we are going to divide both sides by m this time. because we want to cancel out these two m's here and end up with a by itself. All right, so we're looking for this number here. Now our new equation looks like force divided by mass is equal to acceleration. So that's 1,792 divided by 56 will give us the acceleration. And in this problem, our acceleration is 32 meters per second squared. All right, make sure that you keep these units here. All right, because if you just put meters per second, that's just speed. All right, that is not the units for acceleration. Acceleration is always meters per second squared. Okay? Okay, so what do you do next? What you guys are going to do is go back into your Google Doc or your Google Classroom, and you can either complete option A or option B in this assignment 2. All right? There will be a worksheet giving you different calculations, and you can practice calculating Newton's second law, or you can complete the interactive activity where you play along with the different scenarios. Okay?